All right, today we are diving into one of the most powerful, most dramatic forces that literally shapes our world: volcanoes. Let's get right into it.
So what force can build entire islands from scratch and also level entire cities? Well, it's a volcano, right? It's this incredible geological powerhouse. It can create new land right out of the ocean, but it also has the raw power to wipe civilizations off the map. So, what exactly is a volcano?
Okay, so at its most basic level, a volcano is really just an opening, a rupture in the Earth's crust. Think of it like a vent. It's a way for all that superheated molten rock, the stuff we call magma when it's still underground, to get out. And the second that magma hits the surface, boom, we call it lava. And that simple act of escaping is what drives literally everything we think of when we hear the word volcano.
So, let's talk about Earth's fiery heartbeat. And really, that's a great way to think about volcanoes. They're not just random, chaotic events. They are a fundamental process of our planet, kind of like a heartbeat, showing us exactly what's going on deep, deep beneath our feet. The basic idea here is actually pretty straightforward. You've got this melted rock, this magma, deep inside the Earth. And because it's melted, it's less dense than the solid rock all around it. So what does it do? It wants to rise. Simple physics. And when it finds a weak spot in the crust, or even creates one, it just pushes its way through, and just like that, a volcano is born. But, and this is a big but, this doesn't just happen anywhere.
So where does this all start? Let's take a look at a crack in the crust, where magma is born. We're going to take a little journey underground to see where this magma actually comes from. It's born way down in the mantle. That's that super hot, kind of gooey, semi-solid layer right beneath the crust. And here's the key. It only forms under very, very specific conditions.
And that brings us to what we can call the three volcano triggers. You've got convergent boundaries, divergent boundaries, and hotspots. Almost every single volcano on this planet can be traced back to one of these three scenarios. So let's break them down one by one.
Okay, first up, convergent boundaries. Picture this. Two of Earth's massive tectonic plates are crashing into each other. One of them gets forced to slide underneath the other one, a process scientists call subduction. Now, imagine the incredible heat and pressure down there. It actually causes that sinking plate to melt, creating a whole bunch of new magma that then rises up to the surface. And if that sounds familiar, it should. This is exactly what creates the famous Pacific Ring of Fire, a huge chain that's responsible for something like 75% of all the world's volcanoes. Just incredible.
All right, trigger number 2 is basically the exact opposite. We're talking about divergent boundaries. Here, instead of crashing together, the tectonic plates are pulling apart. This creates a giant gap, which lowers the pressure on the mantle right below it, and that allows magma to just well up and fill the space. This is happening constantly, right now, all over the ocean floor. It's what creates those vast underwater mountain ranges we call mid-ocean ridges.
And that brings us to our third trigger, hotspots. Now, these are a little different. A hotspot isn't about plate edges. It's a fixed point deep down in the mantle that's just unusually hot. It sends a plume of magma straight up, kind of like a blowtorch. So as a tectonic plate slowly drifts over this spot, the magma burns right through it, and you get a volcano. But the plate keeps moving, right? So eventually it moves off the spot, the volcano goes extinct, and a new one starts to form right behind it. This creates a whole chain of islands. And of course, the textbook example is Hawaii. The Hawaiian Islands are a perfect trail left by the plate moving over that hotspot. In fact, the oldest islands have moved so far away they've eroded down and are now just underwater mountains.
Okay, so we've got our 3 different ways to make a volcano. But that begs the question, why do they all look so different? You've got these huge, gentle ones and these classic, pointy, explosive ones. Well, let's head back up to the surface and explore what we're going to call the 3 volcanic personalities. You'll see how these different origins create totally distinct types of volcanoes.
First up, our first personality, the shield volcano. This is the gentle giant of the volcano world.
Now, the first thing you have to understand about shield volcanoes is their sheer scale. These things are the largest volcanoes on the entire planet. They're built up layer by layer over millions of years from countless flows of really fluid, runny lava. And because that lava flows so easily, it doesn't pile up. It just spreads out over huge, huge areas. That's what creates those super wide, gently sloping sides instead of a steep peak. Mauna Loa in Hawaii, that's your perfect example. And that shape is exactly where they get their name. Someone once said it looks like a warrior's shield lying on the ground.
And that's just a perfect way to picture it, right? This broad, low-angle profile, it's a great visual for these massive but pretty calm giants.
All right, moving on to personality number 2, the composite volcano. You might also hear it called a stratovolcano. Now this is your classic picture postcard volcano, the dramatic, steep, and often very, very dangerous one.
Yeah, these guys are pretty much the polar opposite of shield volcanoes. They're tall, they're steep, they're iconic. Instead of that runny lava, they erupt with this thick, sticky, viscous lava that really doesn't flow very far. And they tend to explode violently. They throw ash, rock, all sorts of stuff high into the air. Over thousands of years, these alternating layers of thick lava and explosive ash build up, and that's what creates that classic steep-sided cone shape we all know. Think Mount St. Helens.
So when you boil it all down, the huge difference between these two types is the lava's viscosity, which is just a fancy word for how thick or runny it is. Here's a super simple way to think about it. The runny lava from a shield volcano, that's like pouring water. It just spreads out flat. But the thick, sticky lava from a composite volcano, that's more like pouring cold honey. It piles up on itself, and that's what creates those really steep sides.
And that brings us to our third and final personality, the cinder cone volcano. This one is the smallest and, in many ways, the simplest of the whole bunch.
Cinder cones are really fascinating because they're not built from lava flows at all. Instead, they form when gas-charged lava is just thrown violently up into the air during an eruption. As it flies through the air, it cools and breaks apart into these little bubbly chunks of rock that we call cinders. These cinders then fall back down to Earth and just pile up around the vent, creating a small but pretty steep cone. What's really interesting is that their eruptions are usually pretty short-lived. In fact, most cinder cones only erupt once. A famous example is Paricutin in Mexico, which literally grew out of a farmer's cornfield back in 1943. How wild is that?
And here it is, all laid out for you. This is kind of the aha moment. Just take a look at this quick comparison. You can see so clearly how it all connects. The shape, the lava type or material, and the style of eruption, they're all linked. You've got your runny lava creating wide, gentle, non-explosive giants. You've got your thick, sticky lava and ash building up to form those steep, explosive icons. And then you have short, fiery bursts of cinders that create small, simple cones. It all makes sense when you see it side by side, and it all traces back to the geology happening deep underground.
So why does any of this matter? I mean, why should we care? Well, understanding these fiery mountains is about so much more than just geology. It's really about learning to read the history and the future of our own planet.
I mean, think about it. Volcanoes are fundamental architects of our world. They literally create new land out of nothing, like the entire state of Hawaii. They give us a direct window, a sample of what Earth's deep interior is made of. And maybe most importantly, by understanding how and why they erupt, scientists can get better and better at predicting their behavior. And that helps protect the millions and millions of people who live in their shadow.
You know, from shaping entire continents to affecting the global climate, volcanoes have been writing our planet's history for billions of years. So the question that leaves us with is, what will they tell us about its future?